classification, matching, these are all coming under recognition. Okay. So the first two modules we were talking about the classification, and this module we'll be talking about matching. Okay. And I told you that matching is also a part of recognition. So that is why we are going for matching. So when we talk about this pattern matching, we need to go for two different types of recognition models. That is, number one is statistical, and number two is structural. Okay. So these two are the different pattern recognition models for pattern matching. So what do you mean by statistical pattern recognition? And then we move on to the structural pattern recognition. That means there are some disadvantages that we find it in statistical, which would be supported by the structural pattern recognition model. Okay. So whenever we say statistical pattern recognition model, we always need to have some quantified values for making a decision. Something like, what is the mean of this pattern? What is the median of this pattern? What is the standard deviation of this pattern? What is the variance of this pattern? And these are all some of the statistical models. And we also try to find the covariance, and we also try to find the similarity of the patterns using some metrics, similarity metrics. And these are some of the recognition quantity through which you will be able to make a decision. So that is what the statistical pattern recognition is all about. Let me read what this statement says. Statistical pattern recognition attempts to classify patterns based on a set of extracted features. Okay, so you need to extract some features. Okay, and in the CBOS and that example, we were talking about some features, right? Feature in the sense, what is the length of the fish, number of fins of the fish, what is the color of the fish, okay, what is the breath size of the fish. So these are some of the features that we have already seen. So that is a feature. So it attempts to classify the patterns based on set of extracted features and an underlying statistical model. So here is where we talk about the mean, median, standard deviation, variance, and covariance, and any other similarity metrics. So that is where this statistical model is all about, for the generation of these patterns. Okay. So using this, you make a recognition model through which a matching is happening. That is called statistical. Ideally, this is achieved with a rather straightforward procedure, like we determine the feature vector, that is what the number of fins, the length of the fish, and so on and so forth. And you need to train the system and then classify the patterns. Okay. So once you classify the patterns, then further process is matching. Okay. So before you do matching, you can also have a classification. Unfortunately, there are also many problems where patterns contain structural and relational information that are difficult or impossible to quantify in feature vector form. Okay. So there are some problems. There are some patterns where it contains some structural and relational information. Okay. Because the matching will happen only based on the structure. I'll just show you an example in the next slide how the structure is being could be classified or could be matched. And relational information, there is a relational information of the particular object. So For this kind of complicated problems, it is very impossible to quantify with the available feature vector. Okay. Say, for example, we will take the same case of the fish. Okay. And how are we classifying this um, salmon and sea bass based on the feature vector? In the future, we are just looking at the length of the fish. In the future, we are looking at the number of fins of the fish and these kind of stuff. There is no information about the structure of the fish. Here you cannot have a structure. That is why we'll be able to solve this fish problem using a statistical pattern recognition model. Why? Because all types of fishes are having a same structure. Am I right? You take salmon, you take sea bass, or you take any other fishes. It has a general structure, right? It has a general structure. But say, see, for example, you have another type of fish called seahorse. You understand what I'm trying to say? There's another types of fish or the sea animal, which is seahorse. But can we, when you look at the structure between the seahorse and any of the fish, you find a structural difference. Am I right? You find a very big structure difference on this salmon and the seahorse. Though we call seahorse as also a fish, but there is a vast structural difference. So here is where the statistical pattern recognition model fails. Okay, fails. So that is why we are forced to go for a structural pattern recognition model. You understand in what case we need to go for statistical pattern recognition and in what case do we need to go for structural pattern recognition? I have given you an example. Am I right? I don't know how many of you are listening. I have given you a very, very important point. The difference between structural and statistical pattern recognition. And which are the problems would be sufficient with the handling of statistical values and which are the problem could not be solved with statistical pattern recognition models. So keep that in your mind. This is the reason why we are going for structural pattern recognition. Okay. So coming to a structural pattern recognition models, just look at this diagram. Okay. So this diagram, the picture given to us is a square over here, a triangle over here, right? A square over here, a triangle over here. What does the structural pattern recognition takes as an input? Takes as feature, I would say feature, okay? The number of segments, the number of line segments, how many number of line segments you have? That's a number one statistical value, right? And number of horizontal segments you have 2, and number of vertical segments you have 2, and number of diagonal elements you have 0. That's absolutely fine, but when you give these inputs, number of segments 4, number of horizontal segments 2, number of vertical segments 2, number of diagonal segments 0, how many of you will be able to recognize these features are taken from a square? Am I right? These features are taken from square. So it is very hard for a system or even a human being to understand from these features that the given picture is square. right? So that's a complicated thing in statistical. Whereas in structural pattern recognition, what we do here, horizontal and two vertical and one horizontal. No, just like the, you know, a picture, just like how you narrate a story to a system, you're just making an explanation. Am I right? So first you draw a horizontal line and you draw two vertical lines from the end of the horizontal lines and then connect the horizontal line, right? Then we can say that this is either square or rectangle. Am I right? Am I right? So now you have only two options. Now you have only two options, either square or rectangle. Somehow you have confined your parameters into a near solution. Am I right? So that's called a structure, the advantage of this structure. It doesn't have a feature values as quantity, right? Whereas we always talk about in the sense of strings. Am I right? Horizontal is a string, right? Is a text string. Vertical is a string. Horizontal is a string. So hereafter, in the structural pattern recognition, we are going to play with strings, not with the quantity. Okay? Fine. So is the case of triangle. Number of segments, 3. Okay, you have 1, 2, 3 number of segments. And number of horizontal segments, you have 1. You see, number of 1 horizontal segment. Number of vertical segments, you don't have anything. But you have 2 diagonal segments. Am I right? 2 diagonal segments. So this is a representation of triangle with the statistical pattern recognition model as a feature. But whereas here you have 2 diagonals and 1 horizontal. So you have got a string, 3 strings to discuss. So with these 3 strings, we'll be able to make some matching. Yeah. Yeah. So this structure quantification, this is structure, okay? This is a structure quantification. This is the structure quantification. Okay? This structure quantification and description are mainly done using formal grammars and relational descriptions, principally graphs. Okay? So we are going to discuss about the formal grammars and relational descriptions. Okay? So hope you have studied, you are studying theory of computation, am I right? Can I get some response? Are you doing theory of computation?
Yes, sir.
Yeah. So, yeah. So the theory of computation will be helpful for you in this case. And we are going to talk about grammars. Okay. So please make a note that you are studying theory of computation. And I don't know whether your course teacher have given you the applications of theory of computation. Pattern recognition is a very, very prominent application where you are using theory of computation. Okay, so don't think that theory of computation, what is the purpose of studying theory of computation? By now you may have a feeling that, oh my God, what am I studying? Is it useful for my career? What is the use of this theory of computation? Fine. So you might have received a lot of questions in this angle. So I'm telling you that in pattern recognition, you are going to apply the grammars which you are studying in the theory of computation. Okay, and the relational descriptions. Then recognition classification are done by, so this is a structure quantification is done by formal grammars and relational description. What do you mean by structure quantification? See, you just look at this. These are all a structure definition. You understand? Horizontal, vertical, okay, and horizontal, these are all structure definition. And this structure definition has to be converted as a quantification. Okay, so that means we need to give a value for these structural definitions. Of course, statistical has a direct quantification, right? So there you need not require any formal grammars or any descriptions. But whereas here you need a formal grammar and descriptions for you to move forward for an algorithm to understand the concept. Okay, for an algorithm to understand the concept, we need to quantify. That means we want to have some quantifiable value for any structural definitions. These are all structural definitions, okay? And as it is, the system will not be understanding. Okay, as it is, the system will not be understanding. So in order to make these structural definitions to be understandable by the system, we need to go for formal grammars. You understand why? I'm just telling the answer for why. Why do we need to go for formal grammars? Why do we need to go for relational descriptions? Okay, and then the recognition and classification are done by parsing the formal grammars and relational graph matching. Okay, so this is purely theory of computation concept. This is purely theory of computation concept. Okay, so we will study strings. What do you mean by strings? These are all strings. Am I right? These are all strings, right? Each string is the structural definition, right? Okay, we'll study about strings and we will look at the formal grammar methods. What is the use of grammar? What is the use of grammar? Can anyone say? Hello? What is the use of grammar? Answer is here. Tell me, what is the use of grammar? Anyone?
Structure quantification.
Structure quantification. So this is a structure definition and I want to have a quantified value for this string. Okay, for which I need to go with this grammar, right? Okay, and graph theoretic approaches. So you might have studied graph theory and all, right? Have you studied graph theory in your mathematics? Can I get answer? Graph theory? Yes or no? Have you studied graph theory?
Yes, sir.
Only Tejas is responding. How about others? Are you all here? I don't know. I'll just call randomly one guy. Huh? Bharani, are you here? Mr. Bharani? Mr. Bharani.
Sir.
What are you doing, Bharani? What did I teach? Can you tell me?
Sir, what did you teach me?
Bharani.
Sir.
What am I teaching?
Sir, grammar teaching, sir.
Grammar, English grammar, huh?
Yes, sir.
Present tense, past tense, future tense. I'm not teaching grammar. Grammar is going to be the next concept. Thambi, gavaningappa.
Okay, sir. Okay, sir.
Don't think that I'm teaching to computer. It's all for you. Huh? And I have given you industrial visit opportunity and all, but none of you are coming for Once they make some strong, hard and fast rules, you guys are not coming. Huh? And you always wanted to visit Lulu Mall. Huh? If Lulu Mall is there, then everybody will come. What is this? Huh? Industry visit, no? It should be an industry visit. You should go to the industry. I came to know that people are not interested. It's very, I felt very sad about it. I'm not like any other department, Spectrum Technologies. Just go and two of you will go and get the certificate by paying 200 rupees per head. What is this nonsense, IVs? Huh? So I don't want to make such a, trip and all. When we say it is IV, it should be industrial visit. Come with a very good industry and try to, get things what is really happening in the industry, and you will get a chance to speak with a few people over there, and you can expose your talents there. There is a chance of getting a job once you go there. So and all, we should have it in your mind.
Sir,
Yes.
sir, how do we contact an industry, like to ask them, like, what would be the best way to reach out to someone if we want to?
Yeah, we have a lot of contacts here. We have a lot of alumni students here working in companies. I thought that somebody will come and approach me. I have connection with industries here.
Okay, sir. We'll come.
You
with-
come.
Yes, sir.
And I know some of you also can help. I'm sure that some of your siblings and some of your parents even working in industries, and even you can also help, so that you can go as a trip, go there and get exposure. Some of your parents, friends and your siblings are working in industry. Through them also you can contact. Yeah, lot of opportunities are there. Just we need to send a email to them or connect with them and find out the procedure. Okay, fine. Martin sir, time is there. What's the time?
Sir, 4:25, sir. We have around 15 minutes, less than 15 minutes, sir.
Okay, just I'll take another 5 minutes and I can leave them. I'm very sad that very few people are listening. And yeah. Okay, so as mentioned in the previous slide, that we need to work with the strings because the structural elements are talking with strings, and we need to work with strings. Yeah. And recognition with strings. That's the next slide. When we talk about strings, I'll be randomly asking questions. Everybody please listen. I'll be randomly calling few people and ask them to reply. If you are not responding, Martin sir, please make a note of them. We need to mark absent for that.
Okay, sir.
Suppose the patterns are represented as ordered sequence, okay, or strings of discrete items, as in a sequence of letters in a word, or in a DNA basis in a gene sequence. So now from this you'll come to know what do you mean by string. What do you mean by string, right? So string is a ordered sequence. String is a ordered sequence, okay? And the string is discrete items, okay? The string is sequence of letters in a word, or DNA basis in a gene sequence, okay? These are all called, we can call it as strings. And you can see this is a string, am I right? This is a string. So now we are going to play with the string. So here are some definitions. String elements are called characters. String elements are called characters, or we can even call it as letters or symbols. Okay. These terms we must know. Okay. Hereafter, when we talk about the grammar and relational descriptions, we will have only these terms hereafter: character, word. Okay. String representation of a pattern is called a word. Okay. That means this is a word. Okay. We generally call this a string, but in a string also we have some definitions. We call this as word. And in this word, you have H as a string element, O as a string element, R as a string element, I as a string element. Understand? These are all string elements or characters. A particularly long string is denoted a text. Okay. A particularly long string is denoted text. So maybe the text will have a collection of word. Understand? Text is a collection of word. Probably I would say statement. Any continuous string that is part of another string is called a factor. It is otherwise called a substring or segment. Now you know what is substring and segment? Yeah. So we call that as a factor. So character, word, text, factor. These are some of the definitions which we are going to use in the next 2-3 slides. Okay. 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 So these are all some of the important pattern recognition problems that involve computations on strings include. So we are going to discuss with pattern string matching, string edit distance, string matching with errors, and string matching with don't care symbols. Okay. So I'm not going to read this and make you understand. I'm going to directly show you some examples so that you will be able to understand all these 4 pattern recognition problems with strings. Okay. Okay. So as I said, the first problem is string matching. Okay. String matching. What is this string matching? I told you, no, this is a text. This is called text. Fine. What do you mean by text? We have given a definition, right? This is called text. A particularly long string is denoted text. So that's what given here. This is text. Okay. And now you have something called X. X is a string. We call this X is a string. So this is a pattern that I want to match. This is a pattern I want to match. Okay, please note that the problem given to me is string matching. And this is a pattern I want to match from the given text. So I'm coming from the starting place and I'm moving. We call this as shift. Shift. You can see this shift. Okay. And you are making the first shift, second shift, third shift, fourth shift, fifth shift. After making the fifth shift, you will be able to find the string S, X, B, D, A, C. So that means the S value is 5. What is this S value? 1, 2, 3, 4, 5. There are 5 shifts. After the fifth shift, you will be able to match the given X with the text. So that means the shift S is equal to 5 is a valid shift. Is a valid shift. Understand? That is what string matching is all about. Okay. The second thing, string problem is string edit distance. Okay, string edit distance. What does it mean? you have X string is given, okay, and Y string is also given, right? And we need to make some edit on the X string so that our Y could be reached. Okay, you understand the problem? X string is given and I want to make some edit in this X so as to transform this X into Y. Okay, so what is X? Is excused. It's a source string. And now the target string is exhausted. So what are the strings that I need to edit? The edit operation can be insertion, can be a deletion, can be a replacement or substitution. Okay, so these are the predominant 3 edit options that one must have, one can have, or one may have. So E is okay is matched with the first character, X is okay is matched with the second character, but we need to have H because the third letter is H. So here you are seeing as C. So you need to substitute C to H. Okay, so substitute H for C. Okay, then after that you need to insert A. Okay, insert A. Okay, exhaust. Then T should be inserted, and finally you will be achieving the target string. This is called string edit distance. Hope you are able to understand what is it. Okay, so coming to the next problem, string matching with the errors. I'll be just going directly with the problem. You have got a text. This is text and this is X. This is a X which is a pattern to be matched. And once you make the shift, you'll be able to make a maximum character matches in this particular shift, 11th shift. That means you are able to match 1, 2, 3, 4, 5, 6, 7, 8. Out of 9, 8 characters are matching in the text, but only with one there is a mismatch. That doesn't matter. We call this a string matching with errors. Because if you miss this particular matching location on a particular shift, you will not be able to see this pattern anywhere in the text. So even if you find a string matching with errors, if the error is very minimum, we will be able to accept the pattern matching. Okay, that is what string matching with errors. And
Sir, can you explain this once again?
pardon? You want me to repeat?
Yes, sir. String matching with errors.
Yeah, string matching with errors. Yeah. So this is a given text and this is a given pattern X. Okay. You know that this pattern X has a meaning into it, structure, right? Structure, right? And you are just starting this pattern for a matching with all the shifts here. Okay. First shift, there is no match. Second shift, there is no match. Third shift, there is no match. Because anyway, you have 9 elements over here. It's always better to start with the 9th element. Okay. That is shift equal to 9 directly instead of going for S equal to 1, 2, 3, 4, 5, 6, 7, 8. And directly you can have with 9. And when you match this structure, this pattern X, with this first 9 elements, directly you can say that there is absolutely no match. So you will be increasing the shift. Okay. Shift equal to S equal to 10 and S equal to 11. And once you make this S equal to 11, that is the 11th shift, you will be able to find S matching, T matching, R matching. This I is not matching. Okay. And C matching, T matching, U, R, E. all these things are matching. So maximum elements are matching. Out of 9, 8 characters are matching. Only 1 character is mismatching. Right. So there is an error here. There is an error here. And you can make a note of this particular S. And if you want, you can go further, S equal to 12, 13, 14, 15 and all, and see whether there is going to be 100% match. If there is not going to be 100% match, this S equal to 11 could be accepted. That is what I'm saying. String matching with errors sometimes may be accepted with errors. You understand, Mary?
Yes, sir.
Yeah. Okay. So coming to the last slide. This is the last slide. With that, we'll be winding up the class. String matching with, just a minute. Don't care symbol. Okay. So the next one is string matching with the don't care symbol. So first of all, we must know what is don't care symbol. String matching with the don't care symbol, that is this phi symbol, is formally the same as the basic string matching, but this don't care symbol in either X or text is said to match with any character. So when you look at the don't care symbol, you can consider that don't care character as a matched character. That is what the algorithm says. Okay. When you find a don't care symbol, that is this phi symbol, okay, this phi symbol, you can consider them as a matched character. So no need to worry about it. Okay. So sometimes, in what circumstances this particular scenario will come, suppose you are transmitting something in the network, there is a chance of losing the data. Am I right? There is a chance of losing the data. So when there is a loss of data, at that time, you can just fix this don't care symbol. Okay. So when you find a don't care symbol in the lost information location, then you can easily match it with the don't care symbol. For example, this is a text given, and in the text also you can find some don't care symbols over here, right? And this is a X pattern which is coming as a problem, and 1, 2, 3, 4. There's a fourth shift. You will be finding this almost matched with the text. You can see P and A and T with don't care symbol, which is exactly matching, right? That is what the algorithm says. When you are finding a particular character which is matching with don't care, you consider that as a matched character. And T is matching, and don't care is matching with E. Please consider it. And R is matching, and don't care to don't care, match it, and S to S matching. So here it shows 100% match, right? That is what we are saying. So this is for certain applications. This pattern string matching with the don't care symbol would be helpful. Like I said, when some data is being transferred through network and there is a possibility of loss of data, at that time you can make use of this don't care symbol for a pattern matching. You understand what I'm trying to say? Are you clear with this problem? Yeah? Can I get some response? இந்த தம்பெல்லாம் அனுப்புவீங்களப்பா, அப்படியே பறக்குமேப்பா, எல்லாம் அனுப்புங்க. Yeah, that's what I want. Yes, thank you. சும்மா அனுப்பக்கூடாதுடா டேய், ஏதாவது புரிஞ்சா அனுப்புங்கடா. Are you able to understand? Yeah. So thank you so much for listening. Those of you who are listening, I'm so glad that a lot of thumbs are coming. Okay. Thank you, Martin sir. I'm done. Thank you so much.
Okay, sir. Thank you all.